Okay, so it is 1 o'clock. So does anyone have any questions just about older stuff? Just so you guys know, I guess before I open it up for questions here, what I did is I made a couple videos, put them up on the YouTube channel. So there's a mole video just on like what is the mole, um, what do you need to know about the mole, kind of just like a basic background of it. And then I also made a calculating molar masses video, how you add those up. So all the work you can see over here.
Can you put Caleb into here? He's in general.
Caleb's got to click on the physical science thing for him to hop
Oh,
in
he
here.
he just joined. Yes, I don't think he has the role. Oh, he does. Never mind.
Yeah, he does.
Matter. Oh, poor guy.
Okay,
Hey,
so
Dad, did you know? What are you doing? Trimming my face. That's mine. Yeah, no, I'm just borrowing it. It's not for your face. What is it for? Did you read the box?
what is that? Okay, so we're gonna walk through just a couple of these Stoic problems that I released to you guys. I'm gonna do, I think question 4 is probably a good one to do, and then I think also question 4 is probably a good one to do, and then also I think we'll do question 5 as well. So what we need to talk about then, not today, but we're gonna get into limiting Stoic probably in a little while, but I just want to work through these Stoic problems just so you can see kind of how to do them. So I think probably the best thing for you guys to do is just have a piece of paper and maybe a piece of paper, maybe pencil out for yourselves, and then we'll work through some of these problems. So question 4 here. It's plugged in. Yeah. Okay, so question 4 says calculate the mass of sodium permanganate that can be prepared from 1.27 grams of sodium bisphosphate. I don't even know how to say that. According to the following reaction. So we're actually given the chemical reaction. Chemical reaction is 2Mn NO3 2 plus 5 NaBi O3 plus 14 HNO3, and that goes to form 2NaMnO4. Oh, this is the world's longest equation. Okay. Can everyone see my screen? Are we okay with the streaming, how that's working right now?
Yep, it's good.
Okay, awesome. Thank you, Hattie. Okay, so this is the longest equation I've ever seen, hokey lick. I've also never used any of these chemicals before except for water, and I guess sodium nitrate, I've used that too. But what we're asked here is we are asked to calculate the mass of sodium permanganate that can be prepared from 1.27 grams of sodium bisphosphate according to the following reaction. So kind of what we need to highlight for ourselves is we need to be able to identify which compounds we actually need to focus on. So the two that for sure we need to focus on is we need the sodium permanganate, and sodium permanganate is this one here. And we also need to focus on sodium bisphosphate, which is going to be this one here. Tegan, you can, oh, Tegan can't hear me. Left click or right click on my name, either works. Okay, so when we're going through this, we need to focus on these two things. The one on the left here that I have underlined, that is the sodium bisphosphate, and we knew that we had 1.27 grams of this. Okay, and then the other thing that we need is we also need to know how much of this can actually be formed. So very simply, what we need to do is to go from the sodium bisphosphate, we need to go from grams to moles, and then we need to convert to moles of the sodium permanganate, and then we can go into the grams of this sodium permanganate. So the idea is mole is the beautiful thing that allows us to do this conversion, because a mole of anything is just 6.02 times 10 to the 23. So if we know that, we can go from grams to moles of whatever this thing is, the sodium bisphosphate, and then we can go to moles of this sodium permanganate, and then after that, then we can actually convert it there. So what we're going to start off with is the only thing that we have a number and a unit for is the 1.27 grams of this sodium permanganate. And what we know is that we want to use the molar ratio to convert in between these two. And so what we'll need here is we'll need to go to the periodic table and we'll need to add up these molar masses. So for sodium here, sodium is 22.99. So I know that for this value here, I need 22.99, and there's only one of those. And then I need to add in the mass of bismuth, which is down here. Bismuth is 208.98. So I need to add in 208.98. And then I also need to add in the mass of oxygen. I know the mass of oxygen is 16, and I also know that I have 3 of those. Okay, so when I have 3 of those, that right there, these values are going to give me the molar mass. The molar mass. And so I want to take my calculator, and I can find out that the molar mass of this sodium bisphosphate was, what was it, 279? 279.97. 279.97 grams. So we know that because this is the molar mass, this 297.97 grams is the mass of 1 mole of this sodium bisphosphate. So that's the first step here. That's going from grams into moles. The next step then is going to be taking this, and we have gotten rid of the grams, so we can cancel that out. We've gotten rid of the grams. And now what we're left with is we have 1 mole of sodium bisphosphate. And I'm going to put this one on the bottom here so that I can cancel this out and this out. And I actually don't want to put 1 mole here. What I want to use for this part is I want to use these molar ratios. So these numbers that I have here. So I know that in this reaction, there must be 5 moles of sodium bisphosphate for this reaction to actually occur. What I then know is that I will produce 2 moles of NaMnO4.
It was.
Now I can hear Tegan. Tegan, did you get it figured out?
Take that as a no.
Okay, yeah.
Probably not.
Okay. Okay, so what now we've done is we've gotten from moles, we've gone from grams of this sodium bisphosphate here into moles of sodium bisphosphate, and now what we're doing is using the molar ratios. We're using the molar ratios to convert into grams of this sodium permanganate. So right now, currently, the only unit I have is moles of sodium permanganate. So what I'm going to then do is take the molar ratio of this, and what I need to plug in up here in the top section is I need to plug in the molar mass. So I know sodium was 22.99. I would go to my periodic table and find manganese, which is somewhere in the middle, right here, 54.94. And there's only 1 of those. And then I also need to add in 4 times the molar mass of oxygen. Oxygen is 16. I'll show you that on the periodic table here. Here's oxygen at 16. So then when we're going through this, this molar mass is equivalent or equal to 1 mole. Remember that the molar mass is equal to 1 mole. So I'm going to add all those numbers together. I'm going to add 22.99 plus 54.94, and I'm going to add 16 4 times. And you can find that the molar mass is 141.93 grams of NaMnO4. So what we've done then is we've gotten rid of moles, and now all we're left with is the grams of NaMnO4. So the last step that we have to do here is we have to multiply and divide all of these numbers out. So what I'm going to do here is I'm going to take 1.27 and I'm going to divide by 279.97. I'm going to multiply by 2 and divide by 5. And then I'm going to multiply by 141.93. So you can see the equation that I have right there. And what we end up finding is that you will produce 0.258 grams of NaMnO4. And I knew that those were my units because that was the only one that I didn't have canceled out at the end. So again, this was question number, I think it was question number 4. Yeah, question number 4. And that's the solution for that one there. Does anyone have any questions about the steps that I followed to get to that final solution?
How'd you get the 2 moles NaMnO4?
Great question. So this right here, this came from the balanced chemical equation at the top here. That's the
Oh,
same place that this 5 came from. This came from the balanced chemical equation. So the
oh, that's
reason
not
that
an S?
that's a
That's just a
5.
5.
Yeah, that's
Oh,
a 5. Sorry, that's a really poor 5. I'm using a new drawing tablet, so it's a little bit rough, but and so some of the confusion that has existed in the past with physical science is why is this one a 1? Why is this number here a 1 mole, but then this one's 5 and this one's 2? The
yeah.
reason is that this molar mass here, this 279.97 grams, that is equal to 1 mole. So that molar mass is equal to 1 mole of sodium bisphosphate. Same thing happens over here. The 1 mole of NaMnO4, the sodium permanganate, is equal to 141.93 grams of sodium permanganate. So those two values are, even though they have different units and different numbers, those two are equal to each other. In the same way, this middle fraction here, in this balanced chemical equation, we know that for this reaction to happen, you need 5 moles of this, which will produce 2 moles of the sodium permanganate. And so as such, even though, again, the numbers are different, because we have different units, this fraction is equal to 1. So in essence, what we've done is taken 1.27 times 1, 1, 1. But because we have different units, we end up with a different numerical value and a different unit at the end. It's a good question, Michael. Any other questions about this example here? Nada? All right. Okay, so what I would like to do then is I would like to move on to this number 5 here. If an excess of sulfuric acid is reacted with sodium hydroxide, 15.0 grams of water is formed. What mass of sodium hydroxide was used? So draw a big line right across there. And I need more space. Okay, so this is going to be question number 5. And we are told that sulfuric acid and sodium hydroxide are going to be reacting. Well, if I go to my physical science data table here, I actually don't like that one. Let's do this one. If I go here, I know that I'm looking for an acid. And so I know that sulfuric acid, if I ate it, it's icky. I want to grab this SO4 2-, the sulfate. And so when I grab that, I'm going to end up with hydrogen, which has a +1 charge, and SO4, which has a -2 charge. So when I swap and drop those, I'm going to end up getting H2SO4, and that is my sulfuric acid. What I know that's reacting with is I know that that is reacting with sodium, Na+, hydroxide, OH-. I know that that's reacting with sodium hydroxide. And we'll draw this up here just so you can see. The last thing that I know, I actually wasn't told what the total products of this entire reaction were. Instead, what I was told is that if an excess of sulfuric acid is reacted with sodium hydroxide, 15.0 grams of water is formed. What mass of sodium hydroxide was used?
Oh, okay, I see.
So what I would be able to tell from looking at this equation is this looks like the perfect setup for a double replacement reaction. We have a positive, I'll do this in red here. I have a positive cation here and a positive cation there. And then I have a negative anion here and a negative anion there. So it looks like the perfect setup for those double replacement reactions. In other words, this Na and this hydrogen are going to switch places. So let's do that right off the bat here. When we end up with that, we have Na and we have the SO4. We'll keep the charges for now. So the two positive cations, the Na and the H, are going to switch places. Now the other thing that the question told us that water was produced. So I know that if I bring this H2 over to this OH, that kind of looks like it has the potential to become water. We have two H's and an OH. That looks like it potentially might be a water molecule. And as told to us by the question, it was. Now the last thing that I have to do is I have to swap and drop this positive 1 charge and this negative 2 charge. So the positive 1 isn't going to go anywhere because if I put a little 1 beside the SO4, there's no point. But this will become Na2SO4. So then the next step of this will be to balance this chemical equation. I see that I have 2 sodiums over on my right hand side, so I'm going to try to balance that first. I'm going to put 2 right out in front of there. So I have 2 sodiums and 2 sodiums. I'm satisfied. Those seem balanced to me. I'm going to look at this entire SO4 as one unit rather than looking at it as the sulfate and then also the oxygens, just because there are other oxygens present in this reaction. I see that I have 1 of this entire SO4 on the right hand side, and I also have 1 of this entire SO4 over on the left hand side. So I would know that those are balanced. The last thing that I have to balance here is I have to balance my hydrogens and my oxygens. In this first reaction, in this first compound, the H2SO4, I have 2 hydrogens. And then in the sodium hydroxide, I have 2 hydrogens as well, because this 2 applies to that oxygen and that hydrogen as a balancing coefficient. Okay? So what that means is that on the left-hand side, I have 4 total hydrogens and 2 oxygens. Remember, we were forgetting about these ones because we grouped it as the entire SO4. So again, I have 2 hydrogens plus these 2 hydrogens here, so that's 4 total. And I have 2 oxygens. So conveniently, if I put a 2 out in front of that, that entire reaction becomes balanced. So these questions are tough because it takes multiple steps. What we've involved in terms of skills here is swapping and dropping, writing out compounds based on their names, knowing what type of reaction this was. We've identified that because we have 2 positive cations and 2 negative anions, this must have been a double replacement reaction. Creating the products for this said reaction, and then balancing the equation. So there is a whole schwackload of skills that were required just to get to this point. And the annoying part is we actually haven't done anything to address the question that was being asked. What we were asked if 15 grams of water were formed, what mass of sodium hydroxide was used? So this question is actually going to work in the reverse direction of what we did in question number 4. So we know that we have 15 grams of this H2O, and we want to work backwards here. And we were asked sulfuric acid. What mass of sodium hydroxide was used? So we were asked to figure out, going backwards, what mass of this, how many grams of the sodium hydroxide were actually used. So we're going to start this question the same way we did the last one. We have 15.0 grams of water. That's both a number and a unit. So I'm going to start with 15.0 grams of H2O. Now, like we did the first time, what we need to do first is we need to go to moles of H2O. So first step is getting out of grams of H2O into moles of H2O. And so for the molar mass of H2O, I know that hydrogen is 1.01, and I know that I have 1.01, and I know that I have 2 of them. And then I have the oxygen, which is 16, and I know that I only have 1 of those. So I'll let you see that quickly. I'll show you the periodic table to show where those numbers are coming from. 1.01 grams of hydrogen, 16 grams of oxygen, and I knew that I had 2 hydrogens. So we know that this total down here is going to be 18.02 grams of H2O. And what that allows me to do is cancel out my grams of H2O, and I'm left with just moles of H2O. Now the next step that we have to follow is we got to convert into moles of NaOH. So the next step is to go from moles of H2O, which are in the top right now. So what I want to do is I know that I want to get out of moles of H2O, and I want to get into moles of NaOH. Now, based on the balanced chemical equation here, I want to grab this 2 from the H2O because I know that for this reaction to happen, I need at least 2 moles of this. And I also know that for this reaction to happen, I need at least 2 moles of the NaOH. So now what we've done is we have gotten out of moles of H2O, and we have gotten into moles of NaOH. And the last step that we were asked is we were asked to find what mass of NaOH was used. So we've gone from, this is our first step, here's our second step, here's our third step, and our fourth step then will be going into grams of NaOH. So again, we want to use 1 mole of NaOH, and the reason we're using 1 mole is because whatever molar mass we calculate for NaOH, that will be equivalent to 1 mole. So this entire fraction would then equal 1. Looking at our periodic table, sodium is 22.99, oxygen is 16.00, and hydrogen is 1.01. So what we can do is we can take the 22.99, add on the 1.01, and then also add on the 16. And we can find out that that molar mass is equal to 40 grams. So again, that is the molar mass of sodium hydroxide. And that's it. That's all the calculations we need to do. So the last step then will be taking our calculator and saying 15 times, times 1, I guess, but divided by the 18.02. We would times by 2 and divide by 2, but most of you will know there's really no point in doing that because this fraction, 2 divided by 2 is just 1. And then we would multiply by 40 for the grams because this is on the top of the fraction. And what we'd end up finding is that this reaction had 33.29 grams of NaOH were used. And that's our final solution there for that question. Okay, does anyone have any questions about that particular problem that we just did?
Kind of.
Okay,
Would you? I'm probably just like dumb, but
don't worry about it.
would you get the? Oh, never mind. Wait, second. 2.99. Oh, so you got the from adding up NaOH.
This
You
40
got
here.
Yeah,
Yes.
by adding up. Okay.
Yeah, that's the molar mass calculation down here.
Okay.
Yeah.
Thank you.
Mm-hmm. Does anyone else have any other questions? No one has any other questions about that one? Are we okay with that particular question?
Yes.
Okay, awesome. Is there anyone that's trying to click? I know Chloe just messaged me. Is there anyone that's trying to click on the Discord and getting a red X on the actual stream itself?
Nope.
Okay.
Nope. It's probably just a setting for this.
Okay. I'll try to get that figured out.
It's happening to Sarah too.